How's it going, everyone? Welcome on in. Happy Wednesday. We're going to get started with our GPT, our little mini GPT that's going to self-replicate. That's what we're going to do. We're currently building the algorithm. We have it all written out from our plan that we did it yesterday. You can see right here, we've got our plan. We know what we're doing. We've got everything ready to go. So the plan for today, we're going to be finishing the implementation. Where did we leave off? I believe we're around, so we finished this. We've got the embedding, the positional encoding. I think, yeah, I'm pretty sure. A good enough positional encoding. Then we've got our query key value. We did our projections, and now we have to throw it through an intention. I believe we're going to be doing a lot of coding today. I think that's the plan. So we get our own custom embedding layer there, which is just a simple layer right there. Although, it requires grad true? Yes. Okay, good. So we got to require grads. We get the correct dimensions. Then we are going to make sure that everything is good with our feed forward, and we just need to do our forward pass. I think this is where we're at right now. This is where hey, Torva, welcome on in. Good to see you. Happy Wednesday. Looking forward to building our GPT. We almost got it. We're almost there. We've got a few things left to do. Actually, we got a little more than a few things. We're going to train on big data. We're going to train on this file specifically. And then we're going to have it regenerate itself. And then we're going to have it run itself to regenerate itself. I think so cool. Hey, how's it going there, Neon Java. Welcome on in. Hey, Neon Java, are you a Java fan? In the kind of Java that you're talking about, like the JVM, the Java Virtual Machine? Is that you? Are you a Java fan? Well, I hope that you enjoy Java because this is something that is not my favorite. I don't know. I have some problems with Java, really. I do. I have some problems. It's too verbose. Wait, are you living on Java? Oh, yeah. Or that too, right? You could be consuming Java. Like, isn't that a coffee beverage? That could be that too. Or, like Torv was saying, maybe you're just only using Java. You could be. You never know. Thank you for clicking the hi button, though. All right, so where are we at here? Let me get my Windows set up. Java is an island state. Oh! All right, Torva, I didn't even think of that. All right. Well, I didn't think that was a place. I thought it was a thing. I thought it was an abstract, it was a language, and it was a consumable. Apparently, you can also live there. Hey, Loons, good to see you. Welcome on in. Happy Wednesday. How are you? Doing pretty good. Yep, we're going to get our AI going. We're going to get it going. We're making it happen. It's getting going. How are you? I'm good, yeah. We're doing good. We've got almost everything we need to be successful. I believe there's nothing in our way to be successful. I think I have the full picture. Java backend developer specializing in Minecraft server development. No way, really? That's amazing. Hey, Neon Java. Thank you. I play a lot of Minecraft. I do. Although I play on Bedrock. I don't play the sea base. I work on the sea base. I like Bedrock. How's it going there? Curious K7, welcome on in. Good to see you. Good to have you guys here. Neon Java, though, thank you for the multiplayer experience. I very much appreciate it. Actually, it's very similar to what my company does. My company is PubNub. We are an API provider for communication. Multiplayer gaming, that's a big industry for us. Gaming is huge. In fact, one of our first customers was an RPG that had built-in multi-user RPG. And this was, many years ago now. Was it like 2010-ish or so, maybe? Around that range? Maybe it was after that. I don't know. It was, many years ago. They were paying us a lot of money, too. We were profitable. Okay. So where are we at now? Where are we here really quick? We've got our query key projection. We got our softmax activation on the output. We do need to remember that. We can't forget that one. On the feed forward. And then on our projection on the output, we need that as well. Do we softmax after? Where do we softmax at? I know we softmax here. We also softmax after this layer here. How's it going there? Hey, it's going great. Thank you for asking. Welcome on back. Good to see you again. Ox. Wait, I don't know how to say your name. Let me see. Let me see if you've got a different name. Good to see you. Welcome on back. Good to have you back here. Go to channel. There we go. Let's see. Oh, all right. I checked to see if you have another name registered under your alias, and you don't. You just have YXNGRX. That's crazy. I found you on Instagram. No way, Neon Java. Are you serious? Hey, you're here. This is where those Instagram reels come from. Is this stream right here? This is where they come from. Money. I love money. I know, right, Loons? Call me Rhythm Man. All right, Rhythm Man. I'm going to try to remember. I'll try. It might be tricky. Hey, Gun Heist. Good to see ya. Building SLM. Yep, that's what we're doing. We're doing that right now. Let's go, Steven. Thank you. Appreciate it. That's so nice for you to say. Yep, we're building that right now. On our output projection, we want to do another softmax here, right? Softmax, I think. I'm pretty sure. Hey, Quick Fix. Good to see you. Welcome on back. Good to have you back here again. We're continuing. We're making it. We're doing SLM, you guys. We're going to have the AI write itself and then retrain another clone and rewrite itself and retrain a clone and go in a loop. And then that will be the victory when we see the screen just constantly looping and regenerating. I think that's going to be neat, right? Yep. That's what we're planning to do. We're going to do it. We have to do other things, though. We need our dictionary as well to go into we need to tokenize better. We need a better tokenizer. So that is critical. It's absolutely critical. So we need our dictionary. Dictionary must tokenize better. It needs to tokenize better. What's that called? What is it called? Self-replication? I assume. All right. That's what we're going to call it. An AI that's generative AI that's going to generate itself, retrain itself on itself to produce itself. It sounds really neat. I know it does. It's actually pretty straightforward. It is. It's functionally, we should be able to achieve this very well. All right, so we need to do this right here. We already did the training on basic math. We already finished that. We did the batching and shuffling. Although, did we though? We need to review this. We need to review that just to double sure. The positional encoding, I think we're good on. I think we succeeded there. So let's put a green check mark. And we're good there. It's pretty cool. I think so too. I'm really excited about it. I think it's going to be great. Okay. So let's get going here. Where are we at right now? So we have all of our attention projections. We got softmax for the attention. Oh, we didn't do softmax. Here we go. Oh no, we did. It's right here. We already did that part. Perfect. So we've got our attention. Is there anything else that we want to... Oh, we don't have the mask. Do we need the mask? This is retrieval augmented duration. Could be cool too. Yes, that's one of the ideas. So we've got our ideas. Let me see ideas here. Streaming ideas. Hey, Derek, good to see you. Welcome on in. Happy Wednesday. We're continuing from where we left off. Yep. So we have a RAG right here. This is what we're going to build. We're going to build it with Rust and Axum. This is going to be a future stream. We're going to do this. Oh, and blood. Hey, I was going there. All right. Foodie. Hey, Foodie Destroyer. Welcome on in. Good to see you. What's he say there? AI. Yes, AI. AI. You're right. That's what we're doing. It's all about AI, you guys. So we didn't do our attention mask, though I suppose we could do that right now. Do we want to? Do we need an attention mask? Do we really need one? We also didn't do, what do you call it? Multi-head. We didn't do multi-head yet. So we also need to do that, which is just a transformation of the dimensions during the multiplication, during the splits. So I think we should be fine. We could easily add that after. Let's see. You're building a wrapper for an agent plus a retrieval augmented generation to detect malware. Ooh. Yes, you're going to do what Microsoft did. They created an agent harness that was so powerful that combined the power of all the different agents into building a really good malware detector. That is going to be valuable. It's not a decoder without an attention mask. Okay. So Derek, all right, we got to do it. We got to have our mask here. So let's see, def. Well, you know what? How about this? Mask equals, I think we could, we already have a mask around here somewhere, don't we? I thought we did. Mask here. It's around here somewhere. It's this right here. Right here. Generate square mask on the embedding size. So we can do that. Size 1 if batching. Okay. So I think we can do that. It's not a decoder. Okay, right. Okay, so let's do it. All right, we're going to add it. Derek, you said it. We got to do it. We got to do it, you guys. Now, do we recreate a new mask? We don't really need to. We only create one mask, right? A mask will be the same either way, as long as the dimensions are equivalent, divisible, right? We need an even division. So let's see here. So let's copy that, go back down to our mask here. No. You know what? We can just grab this one right here. We'll call this the decoder mask. That's what we're gonna do, decoder mask. New kind of transformer is up here. All right, where's that at? The Steven former. Wait, where'd it go? Here it is. Okay, so I think we could self.decoder mask equals. We do this. Is that good right there? Oh wait. Wait. No. We have to create it because it could have different input sizes. So we have to dynamically create this. Oh darn it! I thought it was that's fine. It's fine. Small language model. You got it. Hey, Monkey D. Luffy, welcome on in. Good to see ya. Happy Wednesday. Welcome on back. Yep, we're building an SLM. There you go. Exactly. We're going to be building it's called a Steven transformer, which is just a regular transformer, doing the decoder layer. It's the decoder layer. So we're going to stack. I believe we're going to stack several transformers on top of each other, right? Using the decoding pattern, and then we will update our transformer with this new model that we built from scratch, and then we're going to train it on this exact file, this data right here. So that way it can regenerate itself and then retrain a new copy of itself. Small language model. There you go. You got it. All right. But we're gonna give it big language energy though. That's what we're gonna do. Big language energy. Okay. Where are we at? Where do we want to go? Here. I'm going to make the window a little bit bigger so I can see more. All right. This is to do rethink the tokenizer. We got to do that right there. Good job, monkey. All right. So where is the thing that I want? We're going to have to do a lot of cleanup. Wow, there's a lot of stuff to do here, you guys. Okay. So where is my forward? I think we have to do this here. We're just going to call it mask. I think we have to do it here, and it always has to be, and it would just be on the query. Perfectly fine, query. And we need to do batching as well, I believe, during the training process. We'd be fine. You would build SMTG of your own, like your own tokenizer. Yep, byte pair encoding. Yeah, hey, yes, byte pair encoding, num file. Or your own attention would be cool. Yes, so I was thinking about this yesterday and today. The attention mechanism split. The multi-headed attention, pretty great. However, I think there's a part missing. When you create your tokens and you throw them through an embedding layer, you're going to get a bunch of feature parameters or dimensions, right? And if you're going to split those into heads, you're going to do self-attention on each of those heads. However, aren't you going to miss attention between some of the features of the tokens between the heads? Wouldn't it be better to slide the window across the heads or do different variety of head attention? I think we're missing some valuable insights there. I think we are. You always watch my clips? Hey, that sounds great, Daniel. All right. Really love your energy. Thank you. Appreciate it. I'm fighting with my scroll addiction. Hey. All right. Great to hear it. Daniel, me too. Nice. Thank you, guys. That's so awesome. You wish you were here since part 1. Hey, simulated adventure. It's all good. Don't worry. It's all here on the screen. So we wrote out an entire plan right here, for creating our own from scratch, including the tokenizer and the embedding layer and our own positional encoder, all from scratch, you guys. Well, using PyTorch framework, of course, right? Because we're going to use GPU acceleration backends here. And then our own projections and then our own softmax, which is pretty straightforward, right? That's the attention right there. All right. Where are you from? Where you got this idea? From you guys. from you guys. Thank you for the hearts. I appreciate it. You guys said, hey, what if we did this? I'm like, okay, let's do it. Let's do it. You guys came up with the idea. I tried your own byte pair encoding, but it was built in Python. It was so slow, it couldn't even tokenize 10,000 tokens properly. What? No way it should. Oh, wow. Okay. Well, tokenization of 10,000 tokens, that should happen really fast. Even in Python. Like, we're talking like 10,000 tokens should be at least under a second. Even in Python. I think you could do it. I think you could. I'm pretty sure. You could also just import your own tokenizer separately because it's just converting words into numbers, right? That's all you're doing. Words to numbers. That's what the tokenizer is. Really straightforward right here, right? This part here. Zoom in on this right here. Right? The chat was happy, right? And then 1, 2, 3, 4, for example, right? That's the tokenizer part. Word to token. Pretty straightforward. Okay. So let's see where we can get here. If you want to build the transformer from scratch, you must first create the universe. Hey, that's right. I didn't even think. If you really want it, Derek, if you really want like full from scratch, quarks. The quarks, right? The quarks. You got to make those too. Not even just talking about the nucleuses of the atoms. You got to build the quarks too, right? From scratch, or else it doesn't count. Your own transistors. You got to do everything all the way to the limit. All right, so it's not quite from scratch. We're using the framework of the universe on our side right now, and someone else's transistors. So we've already got atoms that exist. Okay. So I've got a mask here. Query size 1, or we might need to be size 0 depending on our inputs. Although I'm gonna try to natively do this in a batch format first. That's what I'm gonna do, batch format first. You recently watched somebody program atoms from scratch. Did you really? Wait, were they serious? Like, were they doing simulations? Can you actually program atoms from scratch? Is that something you can do? How would you do that? Chemistry? Is that chemistry? Were you watching chemistry, Torva? Okay. Simulation, yes. Okay, got it. Simulation. That makes more sense. I thought there was like a real world situation. All right, so we got our mask. We got a query key value. So let's do our attention. Should we automatically, you know what, since we're already doing that, we should do the mask inside of the attention mechanism. Oh, it's right here. We're already gonna do that. There we go. We're right there. And then we do the mask. Wait, hold on. I see a bug here. Hey, Fairfox35, welcome on in. Good to have you here. Happy Wednesday. Thank you for joining the channel for software engineering. We're building ourselves a lot of AI these days, right? You saw PubNub. It's cool. Neon Java. That's great to hear. Thank you. That's great. Yeah, we've been doing this for over a decade. Our API that allowed communication for games, multiplayer games. A lot of the games on the App Store, they use our technology today. It's really neat. It's great. The biggest games, the top games on the App Store even. This is great. This is great. Thank you for checking it out, Neon Java. That's fantastic. All right, so we could do out mask query key here, and then we could throw out over here, right? Out, right here. Would that work? Is this where we do that? Did we get that right? Where's our attention mask? So attention mask should be on this, even including the square root. Okay. So we have to adjust this here. I want it to be this, like that. Okay, softmax on that. Perfect, okay. Does that look correct? I like how you created nature of programming spirit. Oh, simulated venture. That's very nice for you to say, thank you. Isn't this exciting though? Isn't it really? We're teaching the computer to learn something, right? We're giving it intelligence. It's just very satisfying. It's one of the most satisfying things there is, I think. I used to be really into graphics and making things pretty, so that way humans, when they consume them, they have a really good user experience. Now, the AI is just very satisfying. It's very satisfying. Okay, so let's double check our attention is all you need paper on our correct. All right, so yes. Yep, matmult, scale, mask. Here we go. So here's our matmult scale. All right, so we need to put the mask before softmax, which we did, but the mask needs to include Okay, so we should do... Where should the mask... The mask is in the wrong spot. The mask needs to... the softmax needs to wrap the entire thing. So that it should be matmult, scale, and mask. Matmult, scale, right here. And then mask, and then softmax. Not to, mask and max. 2 words. They sound very similar. Why did I get a timeout for 5 minutes? Oh, hey, Quick Fox. Hey, Epic Blockspo, good to see you. Welcome on in. Happy Wednesday. Welcome on back. Good to see you. Quick Fox, I don't know. Sounds like one of the mods was like, it didn't agree. They didn't agree. I think that's what it was. Use dropout after attention weights calculation. Oh, really? Dropout, really? Okay. All right, numFile. We'll do it. We'll do it. So you want to drop out after attention weights calculation? Attention weights calculation. So you're thinking here. So you say out equals self dot dropout out here. So an extra dropout right there. Okay. All right. Quick fix, not quick fuck. Oh, yeah. Oh, sorry. Yeah. Quick fix. There you go. Quick fix. Quick fix, not quick fox. Yeah. Gotcha. All right. So let's see. Where are we next? Where do we go next? Quick. Because people calling people monkey. Oh, well, there's actually okay. I think there's actually, hey, Quantify Quantum, good to see you. Welcome on in. Happy Wednesday. Good to have you here. We're building our language model. That's what we're doing because Monkey D. Luffy. Monkey D. Luffy's a real user in chat right now. It's crazy how small transistors are. They're so small, right? We saw that. What was that? Somewhere around here. Where was that? There was something someone posted. I don't remember where it's at. Maybe was it up higher? It was around here. We threw it. It was somewhere. It was somewhere on our Discord. Somewhere around here. I love how the billing of anti-gravity works per model. Is it loons? Really? Well, I am enjoying Google's Gemini CLI replacement with AGY, the anti-gravity. I really like it, right? Here we go. AGY, right there. Anti-gravity. Very word CLI. It's unusual. AGY, unusual. However, I very much like this model. I very much like it. Model. Let me see. So we can do high. Ooh, we could do high, you guys. There we go. Boom. High. All right. We'll use that later. And it said that we are reaching the limits of how small transistors can be. Yeah, because what is the ultimate limit, right? The maximum possible limit that we can, at least as far as we can tell, 1 atom. How many atoms are we currently with per transistor? Current minimum transistor size. Do you guys know? All right. Transistor, smallest transistor today, 2026. Size. What is it? Is it like 2 nanometers? 3 nanometers. Okay. 3 nanometers. It could be 2. However, experimental transistors with a gate length of just 1 nanometer using alternative materials like molybdenum, dulcifite. All right. Okay. Are you going to train your own mini GPT afterwards? Yes, we are. Yeah. Well, so we're going to start out by training it on the existing Python code file that we used to train it in the first place. So that way it can print out its own clone, and then we will retrain it. And if once we get that loop going, an infinite loop, then we're going to call it victory. Then we can go even a step further and train it to make our own full-on chatbot, right? We could do it. Dropout is actually after scaled attention. After scaled attention. So not here. So not right there. Okay. So let me see here. Let me see. Where are we at here? Let me see. Let me get the music changed up really quick. Okay. So you said after scaled attention. After scaled attention. Scaled attention. Where is that? Hold on. 1 second. Dropout. Scale. Oh. Right here. Okay. So before the mask. Are you sure? I suppose it doesn't matter. That much. So let's see here. So we've got our out equals. Let's do this. like that. Out. Let me say out equals, we'll change this up here. All right, like there. Okay, so scaled attention, drop out, mask, soft max, then you stick in the value. Hey, Cloudhead, good to see ya. Before soft max, okay. But after mask, so like this or this? Which one? I suppose it doesn't really matter. It would be the same either way, because these do the same thing. They're not going to change much. Why don't train it with Python files so it can code maybe using RAG? Oh, quick found Fox, yeah. All right, so we're going to be on that path. We're on that path. After soft max, sorry. Okay. After, okay, here. Right there, okay. So we've got scaled attention, mask, soft max, dropout, and then we pass in the value. SQ Lighter, good to see you. Yo, what's up? Welcome on in. Happy Wednesday. Good to have you here. It's great to see you, y'all. You used all your Gemini 3.5 quota? Oh, no, Loons. You switched to Claude Opus 4.7? Very expensive one, and it still works. It is an expensive one, right? It's expensive. SQ Lighter, good to see you. Like this. Okay. Attention weights equals softmax attention score, and then attention weights dropout, square root. Okay. Yep. All right. We did it. Right here. Wait. What about this right here? The value. So attention scores. Yep. Tensor, self, torch. Right. Torch, tensor, square root of. Oh, wait. So I've got. This might be a problem right here, is what you're saying. Thanks for clicking the hi button. Can you show anti-gravity? I don't got it. Oh, you don't have anti-gravity? You sure? Okay, sure. So watch this. AGY right here, anti-gravity, right? What I should do is, let's see, PWD right there, CD/desktop, and this is called transformer. Okay. AGY, let me say describe at transformer. All right, there you go. It's off to the races. Quick fix for the second time. Oh, right, I know. Wait, is someone else calling you Quick Fox? Is it possible that I'm calling you Quick Fox and I'm just not recognizing it? It's possible. Steven, check out router on GitHub. 9 router. Okay, let's take a look. Let's see, 9 router GitHub. What is this? Right here. Let's take a look. What do you got? Unlimited free AI coding. Connect Claude Code Codex cursor. Wait. How is it free and unlimited? That doesn't make any sense. Never stop coding. Save 20 to 40% tokens. All right. Well, wait. Hold on. Wait. Why say that right there? Why say that? Say save 20 to 40% tokens with RTX plus auto fallback to free and cheap AI models. Oh, okay. So you basically get to spend all of your tokens across all of your providers and then fall back to free, so you never run out. Okay, that's pretty nice. So always have something available. Hey, Steven, Squirrel Quad. Hey, how's it going, Squirrel? Good to see you. Welcome on in. Good to have you here. Happy Wednesday. Welcome on back. Your code's good. It just uses GPT architecture. You are doing original transformer. Got it, numfile. Thank you. Okay, I was wondering about that. Yeah, I did believe we could. There was a thing that I saw that was putting the dimensions of the current head in the square root as a tensor. And I was like, that doesn't, I suppose it makes sense because you're creating a tensor. Oh wait, we might need to do that right here. Okay, so self dimensions isn't a tensor. Square root requires a tensor. Torch.tensor. Here we go. Yep, all right. So that is required. Thank you for sharing that. Okay. Have you ever used Hugging Face? Yes, I've used a lot of Hugging Face. They have got all the models right there for you to use. You can use any model you want. Isn't it great? Ever used FreeBuff? Quick Fix? I have not. I'm using the native CLIs. So I use AGY directly, or I'll use Codex, right? I use Codex right here. Also status, pretty neat. Check this out. Right there. Oh, what do you see right there? Look at that. Wait, what's going on? I'm running ChatGPT on Amazon. What, you can do that? Yeah, you can. Hey, if you guys didn't notice, check this out. It just came out the other day. if you're using Codex, OpenAI, you can run it on Amazon now. Did you know you could do that? I bet you didn't. I'm pretty sure you didn't. I bet I just blew part of, well, I don't know if it's like revolutionary or anything. I don't know about that. However, I bet I did tell you something new that you didn't know yet. Free buff, quick fix. Let's take a look at free buff. All right, np node package manager js.com free buff. So we're not going to install it because I have to do vetting and things like that. However, we're going to read it. An AI coding agent that runs in your terminal. Describe what you want, and free buff edits your code. Oh, all right. That's pretty straightforward. It just came out. Look at that. All right. Nice. Surely instantiating a new tensor from the torch square root is worse for performance than doing math at square root. Oh, yeah. Cloudhead. I know what you're describing. Yep. Yep. I know it. Hey, what's going there? Rupin, good to see you. Welcome on in. Happy Wednesday. Cloudhead, I see what you're saying. Yes. All right. So this, I'm gonna put it here. So it said Cloudhead. All right. Performance consideration here. Math.sqrt instead dims versus tensor. All right. All right, there you go. I'm going to put that there. I'm going to put that there for now. So that way we know for the future. Also, let me put your real name here at Cloudhead hyphen. All right, perfect. You made a video on the query key value attention, how to get contextual embedding with cool animation. Numfile, did you really? I want to see it. You can check it out if you have free time. I would love to. This is what we're doing right now. It's relevant to the current conversation. Send the link on Discord. Under link share. Here. I don't. Are you here? I'll send it to you just in case. I'm not sure. At numfile. In case. There you go. Discord just for you. Maybe Cloudhead, as long as the computation won't cause it to go off GPU first. Oh, right. Yeah. And it should, because it will probably run on the graph, and I think it might work okay, maybe. I don't know. Happy Wednesday, Stephen Matchstick. Good to see ya. Welcome on in. How late is it by you guys? Mine is 17:38. Mine is 8:38. I'm 8 a.m. 8:38 a.m. is where I'm at right now. Yeah, it's to be the first head, likely under 1 million parameters at this time, so it would probably hurt more. Oh, got it. Want to learn hacking? There we go. We can learn some hacking, you guys. Okay. So we'll think about that at a certain point. This looks good to me. This looks perfectly fine to me. All right. So let's see how. Now let's do our feed forward, you guys. Do our feed forward. So attention, self.attention. Then we're going to go query key value out equals. There we go. We got our attention right there. Attention's all you need. We did it. Although we have not yet built, so we didn't do the multi-headed attention yet. So if we wanted to do that properly, we could do that either in here or outside. So we can concatenate, right? To be honest, dropout wouldn't help much at sub-million parameters. Oh, all right. Well, we'll leave it in here. If you guys say to take it out, we'll take it out. We can comment it out really easy, just like that. You're tracking your IP address. Just joking. Hey, Sergio, good to see ya. Welcome on in. Thank you for clicking the hi button. Happy Wednesday. All right. I think that looks good to me. I think we should have a pretty good performing model if we do this. I send you the link on Discord. All right. Link chat. Let's see here. Let's see. Oh, here we go. Is this it right here? Yeah, it is. Numfile right there. Okay. Let's take a quick look. Get some animation in here.
So in this series of videos, we are going to understand how transformers.
Wait. It's 7 minutes. It's too long. It's too long. It's too long. You're eating some pizza. Nice. This is great. This is great. Hold on. It's I thought it would be like a 1 minute. I didn't think it would be that long.
It requires a powerful mathematics.
I like math, so that's the words you're tokenizing. And then, thank you. So I'm going to click the like button. Okay. So yeah, you tokenized. Oh wait, hold on, you skipped a step. Word embeddings. You went straight to word embeddings. Do we have any tokens there? Hey Sergio, thank you for becoming a member again. Hey, you continued for your a streak for 2 months. That's awesome. Steven is the coolest coder. Well, thank you, appreciate it. Sergio, that's really nice for you to do. I appreciate it. Thank you so much. Thank you so. On YouTube, what's your feed on YouTube? Well, as you can see right here, we've got Claude, we've got some Primogen, right? We got Theo, and then we've got a bunch of other tech stuff. This is for beginners, so skip the positional encoding and other stuff. Okay. Let's see here. Here we go. Here's this attention. Here's the attention. Yep, there we go. Matmul right there. Simple, straight Matmul.
And then by the token, like, and last the token match. We can take same intuition for other rows as well. Now let's understand what values are in Q.
Query key value. Yep.
So far we have decided who to focus as shown in the matrix. Now,
just like you. Is it really? Is it? Nice. We have a similar feed. Okay, yeah. And then, wait. I want to see this right here. 3 tokens. You got n dimensions for the embedding, right? The embedding dimensions. TPU is good for vision. Yeah. Was it tensor processing unit? Yeah. Karpathy, yes. Simulated adventure, absolutely. Famous AI-tician, right? Famous AI scientist. AI scientist is the appropriate term, right? AI scientist. I think it's right. Learned weights. Yep. So you do projections to get your output projection. Yep. And then you create query key and value through each of the projections. And then you go to the next level. Let's see. I'm trying to see here. Right. So you've got your words just as before, right? Trying to skip up here a second. Okay. Query and key transposed. Matrix multiplication creates the attention matrix. Then you need to scale it based on the head, right? Over the under the number of parameters. The square root. That gets you your scaled. Do you also add in the mask? Let's see here. You add softmax. Is there a mask though? Attention weights. Okay. Do you even need a mask? Ever heard of Teachable Machine from Google? Oh, quick fix. I've heard maybe a few times. What is it? What is the Teachable Machine? Contextual embedding matrix. We did it. We did it. Right there. Search it. Okay. Teachable Machine from Google. Oop.
So right now there has been tons of layout.
Okay. Teachable Machine from Google. What is that? What is this? Okay. Let's get a little bit of history here. A free web-based tool that allows anyone to create machine learning models quickly without any coding knowledge. What do you know? It's designed as an accessible, hands-on tool for educators, students, artists, and developers to explore how artificial intelligence works. That's amazing! I didn't know about this. That's really nice. It supports multiple models. All right, that's pretty nice. I like that. And you can train using a model on your web browser to recognize 3 distinct types of input. What do you know? Okay. Images, sound, and poses. Oh, wait, for body. Oh, so this is computer vision. It's computer vision. Classify objects, facial expressions, and environments using local files and your webcam. That's awesome. Classify short 1-second audio samples like words, claps. What's a clap? Wait, what is that? Or whistle using your microphone. All right. That's weird. I don't know what's going on there. I suppose you can classify. So you can say, oh, this is a clap, or this is a whistle, or this is someone talking. Track body movements and physical positions using your computer vision to recognize body language or exercises. This is crazy. I didn't know about this. Did you guys? Do you guys use Notebook LM? Yes, I do, Derek. I use a lot of Notebook LM because we pass around a lot of documents internally at my company because we have, we have a sizable team. And in order to communicate, especially because we're a remote team, we need to be able to document a lot of things. And we need to be able to consume those documents. Notebook LM is a really good way to consume documents. I don't feel I learn as much as if I read the paper and write the code directly. Oh, right. Yeah. Yeah, you are getting a gist. So I think it's really good for internal communication on the company for high level. If you want the full knowledge, you have to go direct to the source. Derek, you're right. You train it using your images, etc. Nice, very nice. That's awesome. Hey, Numfile, thank you for sharing that video. Thank you very much. This was great.
So
Yeah,
in this
I like
series
this.
of videos, we are
This is
going to
awesome.
understand how
Thank you,
transformers
Numfile.
understand natural language. Consider a given sentence.
All right. So let's keep going. Okay, I want... So we need to get back to our code really quick, you guys. We need to get back to our code. Okay. Let's see where we're at here. Let me click the like button there. Okay. So where are we at? Let's close this window. All right. We did our attention with the mask. We did the mask. Scale querying key before matmul. Scale querying key before matmul. This I shouldn't need those parentheses. However, we're gonna do it anyway. We're gonna do it. We're gonna make it. Idea on your own notebook clone. Vibe code using your own large language model that we are building now. Oh, we could do that. We could. We absolutely could. We have the means to do it. We do. We absolutely could. That would be pretty neat. That would be pretty neat. We just need the data set. The good news is NVIDIA last week just open sourced the data set that we could use to train a model to do that. So I think that's pretty neat. Okay, here we go. So we need to finish our forward pass, you guys. Let's keep going. Let's keep going on our forward pass. Here we go. Output attention, self query key value. So that gets us the attention, including the mask. Now, one thing that we don't currently have is the multi-headed part. We don't have the multi-headed part, which we should be fine with because our context isn't going to grow that big and our embeddings are also not too big. Although they are kind of big, we could probably drop them down a little bit since it's going to be a 64 feature dimension. The number of tokens will still be fine, I think. I think it will still be fine. Okay. Yeah. All right. Okay, we should be good. Okay. So let me finish here. So where do we go next? So we've got the attention, and then we need to, I need to jump back to our diagram. Where are we at here in our diagram? So we did this part. Oh, right, we got all the heads. Oh, and then we throw it through feed forward and then a linear output. Of course! Self.feed forward. And then we're going to do self.linear. Wait, do we call this output projection? Here we go. There we go. Right there. Boom. Return out. Done. We did it right there. Check it out. Oh, wait. How's it going there? Good day. How did you write softmax get max probability or something trickier? Softmax is a pretty straightforward algorithm. What it does is it enumerates your entire tensor and it finds all the values and then it creates a scale parameter. It basically finds the max value. So here's what it's going to do. Here's what a softmax is. It's actually really easy. All of these fancy terms, don't worry about it. What it's going to do is it's going to find your matrix. So let's find a good matrix here. Okay. Say this is your matrix. It's going to iterate over your matrix. It's going to find the maximum value. And then it's going to divide all the values by that maximum value. I believe, I'm pretty sure, I think, right? So this is going to give this a 1. Though I think it needs to go a step further. So it's almost like that. Let's see here. I think I'm missing something because all the values need to add up to 1, inclusive of all of the final values in your matrix. So maybe what you do is you add all the numbers together and divide every scalar, which is every number, by that number. So you basically sum and divide. That's softmax, right? Softmax is sum matrix divide, and then divide by, matrix. It's the other way around. Matrix divided by the sum of the matrix. Is that right? Did I get it right? Not simply. It's a bit more. Okay. Oh, there's a bit more to it. Well, I got the sum part right. See, there's the sum right there. So I got it in the right spot. So sum is at the bottom, and then there's some sort of exponentiation here, which I didn't see. Okay, step by step. Let's see here. So wait, what'd you say? NVIDIA is helpful in getting up to speed on the latest AI with their frameworks and education content. Yeah, they are. Guess it's a play to get more people to use their GPUs. You know it. It's exactly. Derek, That's what they're doing. That's what they're doing. Another performance thing would be to use a single linear layer. Oh, for the QKV projection. Yes. I'm going to add that in since you mentioned it. Cloudhead right here. All right. To do. At cloudhead hyphen use a single projection times 3. A 3x projection. Faster. For faster, better. For faster, better right there. And then you chunk 3 dimensions -1. Okay. Input query key value chunk into 3. I'm going to copy what you wrote here. So we create our full QKV like that. Okay. I like that. I like that. That's really nice. There we go. Boom. Right there. Thank you, Cloudhead. Who am I to talk? I literally write CUDA every day. Hey, yep, you're on the NVIDIA world. You're on the wagon train right now. That's where they got you already, Derek. They got you. CUDA's best platform, which is the only reason why NVIDIA is ahead of AMD right now. It is, yeah. They're ahead. They are the leader. They are. AMD is doing pretty good too. They've got the same like manufacturer line, right? They've got access. They just have different architectures, right? I think AMD has mostly been focusing on x86, when NVIDIA, well, they've obviously GPU is their own architecture. They are now focusing on CPU, compute, general purpose compute, with ARM. It ready to train? I'm not expert. Hey, quick fix. It is not yet ready because we have a lot of things that we got to do. We got quite a few things. Though, it's actually not too far off because we've got the full feed forward defined, done, and complete here. I believe all we have to do is start. Well, we need a dictionary. We need a better dictionary. However, we can hold off on that for now because we've got this. So what I need to do is we'll worry about this later. To do later, we need to improve for coding, right? Because right now it's not built for coding. It's built for math currently. So we have to do that. Yeah. Are you one of those millionaire programmers? Hey, how's it going there, Game Dev? Good to see you. Wait. Game Dev guy. Hold on a second. Wait. Let's see here. Good to see you again. We saw you last week. Welcome on back. Good to have you here. And stronger. We're making it stronger. Yep, you got it. Oh, Steven, did you hear about the Samsung worker strike and the result of it? I didn't. Torva, what did they do? Drop that flowchart design image in Discord general chat. The flowchart design? Sure. This right here, which is a giant thing that we've been working on for a while now. Like, look at all these things that we've been doing. It's like one giant. Hey, Loons, you're back. Welcome on back. So yeah, how do I do this? Is there a share button? Okay. Export to link. There you go. I'll put this in Discord. Link share. All right, copy link. Okay. There you go. There you guys go. Ready to go. What about batches? Oh, NumFile, good news. We've set up for batches. We're good to go. We are set up for batches, though our feed forward should still work. Maybe, I don't know. We're going to find out. Can you set up some Minecraft music? Oh, so quick fix. I have only a certain list of music that I could play. I've got it here. And it is the Creative Commons open free YouTube music studio music, right? I only can do so much because I have 106 tracks that I've curated that do not have any copyright encumbrance, which will claim the entire video. If I play even one song, it claims the whole video. So I have to be careful. Gotta be careful, you guys. I do like Minecraft music, though. It's great, right? Oh, the clip producers in Taiwan went on strike because... Oh, the chip producers. They want a cut of the AI boom. They're like, we want a little bit more than our regular pay. We want to become millionaires, too, right? Is that what they're doing? As soon as the strike started, they got it nearly 48,000 workers to receive a $500,000 bonus. Wow. Wow, what a world we live in. That is amazing. That's amazing. That's amazing. The chip boom, you guys. Almost $500,000 as a bonus to be in manufacturing of AI chips. That's crazy. That is craziness. All right. So let me run this really quick. CD... let's see where we're at. Desktop, transformer, Python, transformer. Let's see if we got any problems here. Okay. Looks good, looks good. All right, so it's training on math. This is our original model. So what we need to do is we need to go back and we should try training this on our new transformer. That would be so cool if it worked. That would be so cool if it worked. So what's your OS? My OS is... Here, I'll show you. All right, uname Darwin, right there. Now that is very revealing. If you guys know what that means, I'm running Mac OS. Steven, your prompt engineering real skill, or do vibe coders just call it engineering in quotes because they're insecure? Hey, Mastic, I've got good news for you. I've got good news. There are very efficient ways to work with these agents that provide nearly basically 100% accuracy by working with them using minimal inputs on your, right? You don't want to have like large swaths of markdown files. You don't want to do that. You're just burning tokens if you do that. You have to give them very specific instruction, and they are very typically engineering focused. And you're going to give like designs and algorithms and libraries if you're very specific. Now, the good news is you also don't need to be able to provide the level of specificity to be successful. Though when you're doing things like me at my company, where it's all about very, very important security and network performance considerations, you have to be very specific. So yes, engineers using agentic coding are being very successful because we don't have to write code anymore. We don't have to write it. We have the AI write it for us. However, we're still very much being a design partner in the process. Can I have 1% of that bonus and I'd be happy? I know, right, Squirrel? It would be great, wouldn't it? Your feed forward should be fine with batches as long as the input tensors are shape, batch, sequence length, and model dimension. Yes. Hey, Cloudhead. I think we're good to go there. I think we are. I think. I'm pretty sure. We're going to try it. All right, transformer. Okay, where are we at? Okay, so I've got some interesting bits here. Linear out. So if we are going to just drop in the transformer here, we need to do a couple things because we're no longer doing encoder and decoder at the same time. But that's just English, man. Is it? Put a link in link share. It's the same thing, but on my infrastructure. Loons, really? Okay, let's see. Where do you work? Oh, quick fix. I've got my own company. It's called PubNub. I'm the CTO of PubNub. Thank you for those of you who are new in here. Welcome on in. I started PubNub over a decade ago with my co-founder, Todd Green, who's the CEO. We raised 134 million, Series E, 1 billion devices on my network, 68 patent claims. You can see them in my LinkedIn. They're there right now. They're there. Yep, this is my company right here. It's PubNub. We provide communications for in-app experiences. That means like multiplayer games and on-demand delivery, order delivery, right? We've got a lot of customers. Check this out. This is what we do. This is what we do, you guys. The basic prompting is English, so you need 100% to understand and describe the specifics of what you want. You need to know the entirety of your result to further implement it. Torva, yes. That's what you're talking about. He's CTO of guys. Yeah, exactly. Of PubNub. That's it right here. Yep, it's real. We're live on YouTube. You launched Acceledraw instance? Nice. Quick fix, cool. Great to hear. Welcome in, everybody. Be sure to hit that like button. Squirrel, thank you. Appreciate it. Do you need Angular devs by any chance? Or full stack at least? So we do have jobs posting. Let me see. I don't know. Our company hires with what we need. So go to careers. And it looks like we need... Oh, we just hired one. Oh no. Okay. So senior software engineer for AI and ML and large language model systems. That is currently open. We got an opening there. That is the current opening. Okay. So Loons, you said something on Discord here. All right. What do you got? You can also do Scaladraw. Oh, no way. I didn't know you could do that. Really? Look at this, you guys. Loons, that is... How did you do that? Did you do like some sort of proxy? What'd you do? How'd you do that? Wait, this is neat. How'd you do that? The other way around is somewhat useful. Knowing how to prompt is useless if you can't understand, and the other way around is somewhat useful. Yeah, somewhat, exactly. It's just somewhat. It's somewhat. Join the community. Oh, yeah. Here, let me pin that. Let me pin that really quick, you guys. Pin the message. There you go. Unfortunately, my path is AI, large language model. Not yet. Hey, well, keep on going. It takes a little bit of time, but you'll make it. You'll make it. Oh, Excalidraw is open source, so you're just hosting it. Got it. Okay. And somehow you copied the you copied the original, all the original stuff. This is neat. This is really neat. Look at that. Oh, that's great. Very nice, Loons. Very nice. Let me see here. Let me see. Okay. All right, let's get into our code again. So I think I need to replace this with the Steve Informer. And if I do that, I no longer need this, because we're doing a lot of the stuff inside the Steve Informer. So these things will stay separate for now. So let's see if we can get it to work. Let's see if we can get it to work, you guys. Moment of truth, self dot. Let's see here. Do we have, where do we do a transformer? Let's see here. Transformer on the feed forward there. Okay. So it's only used here. We no longer need the mask. So we're going to leave that there. We're going to call this a Steven Transformer. Steven Transformer equals, I believe it's called Steve Informer. There we go. And then we need what do we need here? We need dictionary and dimensions. All right, so we just need dictionary for now. Okay. Let's call it the dictionary here. There we go. And dimensions and everything. You know what? Just in case, dims equals dims. For now, we'll do that. Okay. You can't click the link to go on the mobile? Oh. Let's see here. They use the same weird system to share. I just put the JSON. Oh, at the end of your instance. Okay, got it. All right. Right here, the JSON equals. Okay. Oh, wow. Wait. Very interesting. Okay. Let me see that really quick. So wait, is this that? All right. However it works. Okay, sounds good. I mean, that obviously can't, that must be some sort of GUID of some sort, right? Because, for example, I've got like big images in here. So it's got to be more to it. There's got to be more to it. Oh, well. Good to know. Okay. Steven profile, there's a link you should be able to click to get the Discord. Oh, right. Yes. Yep. On the, built in there into YouTube. Built right there. Okay. All right, you guys, let's try it. So let's see if I can instantiate. Let's try the instantiation. Desktop, and it's called Transformer. Python Transformer. All right. Any bugs? Yeah. All right. So I immediately got a problem. Okay. That would be Steve Informer object has no attribute number of words. Okay. Sure. Number of words could be here. However, do we want let's see here. Stephen form a number of words. Ah, right there. Okay. So I think that should be fine if we just did that. That right there. Okay. All right. Okay. Oh, wait. Oh, wait, we've got our own embedding here. So okay, so if we've got our own embedding, then we could also, what do you do this? We could also do our own positional encoding. We could do everything inside of here. Mark Lemon, hey, thank you for clicking the hello button. Happy Wednesday. Did you get a haircut? I sure did. I did. Got a haircut a few weeks ago. But it happened. It counts. You programmed something that could say hello in Python. No imports. Wait, you mean like it prints hello text, or does it say hello? Looks good. Thank you, Mark Lemon. Appreciate it. Print hello. Okay, yeah. No imports. That's the way to do it. All right, so let me think about this for a moment. I think we could. Are we actually using embedding here though? See, we're not actually using it right now. So I'm gonna comment this out for now. We'll leave that out for now. And we'll think about how to use this later. Okay. All right, see if we got any more bugs. Okay, so far so good. That just means that it didn't crash. I thought we were a lot further along. So what we need to do now that we've got the Stephen former instantiated, we're going to use the same embedding that we currently have set up. Where are we here? So we're going to keep these as is. And then we're going to do a Stephen former here. We're going to leave this, we're going to comment this out maybe for now is what we're going to do. I think we should just comment this out. So where should we do this? I could just indent it and say def none. So let's say def nothing. Like that. Okay. We'll leave that in there, which is basically going to say it doesn't exist. We don't need these anymore. So those go away. And then on our feed forward, do we want to do a softmax on the final output? Projections out here. Softmax. Okay. Optional. Yeah, we probably want that. I mean, do we need it though? Do we need it? Do you guys know if we need this? Hey, Crafty, good to see you. Welcome on in. Good to see you. Well, good to have you here. Let's see, you said. Okay, good to have you guys here. All right, let's keep going. We got a lot to do, you guys. We got a lot to do. So we got our softmax. I think that was important. All right, let me double check where are we at here. Okay, yep, exactly. Okay, that is on line, where is that? Line 221, that's really, right here. Ah, yes, perfect, okay. So, we don't need this and we don't need that. We also have our question and answer tokens. So we don't need this anymore. This is totally different. So here's what we're going to do. We're going to do old and new. We're going to switch it out. We're going to do an old and new. So this is the old forward. Old forward. We're going to def a new forward. And it only has the query, or well, the inputs. Why not Rust? Oh, yeah, I know we could, right? We could, because we were learning PyTorch. And we want to use PyTorch and become experts at PyTorch. But Rust, it's on the roadmap. We're there. To retrieve the base 64 of the JSON. Oh, loons. It's smart. Okay, so it was an ID. It was. Why do you not read your comment out loud? Crafty? Wait, why not Rust? Wait, Crafty. Oh. Let me see here. Crafty, what'd you say? What'd you say? Stevens Highway? Stephen Baca. Is that right? Oh, wait, Stephen Baca. Hi. Okay. You have duplicate variables names out. What language is that? Oh, hey, Jacob. Hey, Jacob Crosby. Good to see you. Welcome on back. All right, so you know what, Jacob? All right, so why? So you're saying duplicate variables? This is called variable shadowing, right? So you see a bunch of outs here, right? Out equals, out equals, right? A whole bunch of outs. It's called variable shadowing. It's fine. It's just a pattern. You can do this. There's other ways to do it. Rust does this too. So if you're using Rust, this also works. Which you'd be like, wait a second, that can't work in Rust. Rust is very strict. It's super strict. You know what? It works. It works. Why don't you use Claude or some AI to help you? Oh, hey, you know what? Because we're learning. We're learning. And do I have Claude? Yes, I do. Right here. I've got it. It's right there. Right in my terminal window. Right here. Opus 4.8 right there. Are we going to use it? No, because we're learning. We want to learn this. We want to become experts. And I'm already starting to realize alterations that I can make to the algorithms, to the transformer model itself, that could potentially make some leaps in improvement in quality output and performance. Because that's what I've done in my career, is operational distributed compute. I think I can bring some of that knowledge into the world of AI. Sorry, Bakaman. Oh, Big Brother. Oh, hey, Crafty. Okay. I see what you say there. Thank you. When will you go from live? Go from live? Wait, Rajdeep. Rajdeep. What do you mean? What do you mean? I'm not sure what you mean. Hey, X-Dash, good to see you. Thank you for clicking the hi button. Welcome on back. Good to have you here. Happy Wednesday. All right, so where was I on this? What was I doing here? Okay, so we've got a new forward. Got a new forward here. Only on inputs. So we need to tokenize. So we're gonna say tokens. And then we're gonna go embeddings. Embeddings, right? Did I spell that right? We can do self.embeddings. Embedding, and then we put in tokens. Okay, like that. Okay. Then where do we go from here? We need to just throw it through the transformer. Does the embedding auto do positional encoding? Do you guys remember? Or do we need to do positional encoding separately? Let's see, positional encoding. Ah, we're right here. Okay. So we'll do encoded. Pause encoding will equal our embeddings like that. There we go. All right. You want Rust expert? Hey, we will do that. Yep, we are good at Rust. We've been doing Rust since 2018. So that's right. Almost 7 years. Almost 7 years. We will. So we've got a lot of plans, you guys. On this channel, we have a lot of plans. We're going to be doing some Haskell. I want to learn Haskell a lot better. We will be spending a lot more time with Rust and AI. What seems to be the most difficult things in the world when you combine them together, Rust and AI. Also, game development would be a lot of fun. That could be something that we could do later. That's why I became a software engineer, was to do game development. Hey, Sergio with the Rust. I like that. So :_Rust. And we do a heart emoji. There we go. When will you end the live stream? Oh, okay, yeah. So we still got about 50 minutes. We got time. We've got plenty of time. We're not going anywhere. We've got plenty of time here. Let's see. What about WebAssembly? Ooh, we should do some WebAssembly. Yeah. So we could do that. We could do WebAssembly. Obviously, when you target WebAssembly, that's just going to be the container or the runtime or the virtual machine. However you think it. Secure target for assembly that runs in WebAssembly. Nice little container, right? Beautiful. What we could do is we can use Rust to compile to the target WebAssembly. Right? We can do some WebAssembly there with Rust. Chrome use Sandbox for safety, right? I think so. I think they've got some additional considerations per tab that has isolated memory. I don't know specifically what they do. I know they take precaution though. All right, so we've got our positional encodings, we got our embeddings. This part's going to be the same. All right, then we're going to do our transformer, and we need to we'll do one pass, just one pass on the transformer, because what we're supposed to do next is stack them, right? So go out equals self.Steven former, I think. Steven form transformer. positional encoding. There, like that. Return out. I think that's it. See how much simpler it is now? It's so much more simple. Now we just have to make sure it works. If it works, I'm gonna be so excited. If it works, I'm gonna be so excited. To do multi-pass. You usually have to do this multiple times. Let's see, what about sandbox? Why even software use sandbox? For security, right? You don't want any data to be leaked or exposed. That sort of thing. It's actually, it's all about security. Really simple security. Sandbox is, the whole point of sandbox is security. Is it possible to make a new programming language using Python? Yes, you sure could. Why not? Yeah, you can use Python as the bootstrap, which will be the parser for your first language, and then you can build a compiler that also processes your new language so it can build itself. Melco, because it's Python. What's Melco? What do you mean Melco? Yeah, but slow, you want to make new languages use C. Hey, there you go. Yeah, exactly, Crafty. C would be a better choice. C would be a better choice. Okay. Let me see here. All right. I want to see. I knew I was going to get some problems. I know it was. Transformer takes 2 positional arguments. 3 were given. Yeah, uh-huh. So, where are we doing on that? Let's see, 1 second. All right. I need to figure out where our error is. So we've got our dictionary here. Looks good to me. Then line 259. 259 GG. Ah, yes. Okay. So we no longer need to do the shifted. So we just need features. Okay, so this part needs to change quite a bit. Def do nothing. All right, so let me get rid of that for now. And then we are going to replace this. Oh, hey, Fairfox and David, what are you doing over there? Hey, what's going on? Just wanted to say, really enjoying your stream. Keep up the great work. Looking forward to watching more. Hey, that sounds great. Thank you. That's really nice. But I'll need to get some stuff done. All right, sounds good. Derek, good to have you here. Oh, hey, who's that? Was that David? Hey, David, thank you for the follow. Appreciate it. Welcome on in. Good to have you here. We're making our way. We're making our way. We're building our own transformer. We did it. We succeeded. I called it the Steven Former, and it's just basically a decoder layer. We just did this. We did it really simple. You're keeping it simple. Right here is what we built. End to end, our own tokenizer, our own embedding, our own positional encoding, our own query key value, our own softmax self-attention, right? This is the attention, the famous paper, 2017, right? Catenate all the heads, feed forward, and then a linear output. Boom, done, easy. I'm sorry, I can't donate. I'm broke. Hey, no worries. Just being here, and then hanging out with us. That's all you got to do. Thank you for clicking the hi button. That counts. It counts. Okay. Where is my error at? On line 259. You said 259. Here. Oh, right. Okay. So we need to do some epochs. So I also need to rebatch this now. I need to change how the batches are working. Hi, Steven. Hey, how's it going? Bad Redden. Hey, Bad Redden. Good to see ya. Good Wednesday. It's a good Wednesday today. Why even made new language? Making new language not easy. You need to understand kernel and system language. When you make actual proper new language, it's not just overlay. Hey, Crafty. It's mostly from an educational perspective. A lot of people write their own programming languages. Not for utility, usually not. Usually it's for experimenting and understanding how languages work. It's a good step to becoming an expert in software engineering. Writing your own programming language makes you understand how all the other programming languages work. This level of understanding lets you be a better engineer when you're designing your systems. Did you build this from scratch? Yeah, we did, Malcolm. We sure did. We did, and we currently have to do a few things here. We gotta get our batches updated because we no longer are doing our encoder decoder. We're doing ChatGPT, We're doing the modern approach, right? We're modernizing it. Welcome, everyone. Be sure to hit the like button. It's free, squirrel. Thank you for saying again. Do you know about Nightmare Eclipse? I don't know about that. 6x6. Oh, I did hear about something like that. Yes, I did. I was watching the Primogen. How are you doing? Doing good. Thank you for following, David. Appreciate it. Absolutely. Quick Fox. Wait, fix. I said Fox again. I knew it. Sorry, quick fix. I didn't think you. Sorry for doing that. Oh, I'm embarrassed now. Quick fix. Oh, really loving the stream. Hey, that's great. Thank you. I appreciate it. Yeah. This is so nice. Hey, yeah. I'm having a lot of fun. We succeeded in learning PyTorch. I feel very comfortable in PyTorch now. Before, I was only comfortable writing my own AI from scratch because I understood the algorithms are pretty straightforward. It's just a bunch of matrix multiplications, right? Thank you for the hearts. 3 more times and I'll get a free subscription. Hey, I know, I would have to do that. I would absolutely do that. I would absolutely do it. In fact, you know what? We might as well give that a shot right now. Let's see if we can do it. Member gifting. Here we go. Are you ready? You might get it. We'll see. Send now. All right, you guys. Let's see if you got them. Let's see if you got one. Let's see if you got one. Here we go. Gifting some memberships. All right, who got it? Who got them? Hippo with pride. All right. Tanmay. Hey, Tanmay. All right. And Dion. We get Diani. And we've got Raul and Steven. Hey, Steven McBurdy. Hey, we got a similar name there. Dang, I know, right? Quick fix. Ah, so close. So close. Let's see. So there is a specific algorithm that YouTube says assigns. One more time, please. I had it disabled. Wait, what did you have disabled? What was disabled? You can have gift subs disabled. Software engineering just made Notepad with autocorrect and Vim like editor extension support and all without AI. Whoa! Hey! Very nice. Your very own text editor. It's automatically disabled. Really? Okay. All right. Well, what we can do is we can do another one tomorrow because I can only gift twice per month and it's always 5. So let's do another one tomorrow. So quick fix, remind me again tomorrow to click the button. Remind me again tomorrow. Okay? All right, sounds good. All right. You just looked into the SK Hynix, a semiconductor producer, is projected to pay their 35,000 employees a bonus of almost $1 million. Wow. I need to go in the AI business, apparently. That's what I gotta do. Wait for the 6, please. We'll wait. Yep, we'll wait. Keeping it on up. Keeping it up. Please wait. Definitely. All right, you guys. Let's keep going. Let's keep going. All right. So for our batching, we're gonna do a different kind of batch here. Let's see. Shifted. We don't need to do shift. We just need input features. Okay. Let's do batch. We're gonna do new batch. We need new batch. So batch, we'll do batch new. So I think I'm just gonna copy and paste this and we'll do batch new here. So batch new. Indices, yeah. We don't need shifted. Okay. For range and batch size, sample. And then we don't need to shift anything. We just do this. Here we go. Easy, easy. There we go. I love it. I love it. We're making it. We're making it work. It's free for you to gift. It is. Yes, it is. It's free. I can only do it twice per month, though. It only happens twice per month. All the hardware producers are making. Are they making bank right now? Yeah, they are. Because the employees in Taiwan have a profit sharing clause that they get huge bonuses. Whoa, that's crazy. Are you a new streamer? Hey, David, I am on Twitch. I'm new on Twitch. I've been streaming only since August last year. So newish. Newish, right? And then Twitch was only just earlier this year, I think. Or maybe a little bit into last year. I'm not sure. But we didn't start on Twitch. We started on YouTube. So that gives you some insight, right? All right, so we got our new batch. All right, so let's do our new batch here on our, where is this? Do nothing. Okay, get new batch. All right, let's copy and paste this. Here we go. We're going to, all right, good. We don't need shifted anymore. Model, output, none of that. Targets. Do we need to reshape -1? I forgot. Targets, tokenized dictionary. Maybe. Let's try to do the forward pass. Let's see if that works. All right. Target, get batch new. Let's see, get batch _ new. The function we just wrote, you guys, we just wrote it. All right, let's see here. Could you please send us your Twitch account? Yeah, sure. Absolutely. So it is, it's here. I'll just type in Steven LB. There you go. I won the AI lottery. One shot, exactly what you wanted, and it works. Oh, hey, one shot prompt. You did it, Loons. That's actually really satisfying when that happens, right? When the AI gets right the first time. And you like don't have to go back and forth. It's so fast. It's so nice. SK Hynix has 10%. Okay, right. Let's see. All right, Miko. Wait, what about Miko? Oh, on Twitch? Okay. Very good to hear. Okay, so features, output, target, batch. All right, so let's see if this works. Okay, here we go. Questions. Name questions not defined. Okay, right. So line 210. Here we go. Right there, inputs. Here we go. So that was a quick little fix there. Forward there. Okay. Hey! Thank you for the follow. Hey, how's it going over there on the Purple app? Welcome on in. Good to have you here. Thank you. Yeah, we shared it away, and you guys, you figured it out. We're over here. So yeah, we've got sort of the larger screen on the horizontal. Got the horizontal right there. The horizontal. Okay. Grab my screen back to where we're at here. 1 second. Okay, perfect. All right. My eyes, I want to sleep, but I don't want. I know, right, Crafty? I do this in the nighttime too. I'm trying to watch some anime, and I really want to get one episode in, and I'm just so tired because I've been working all day, like everyone else. We all work all day. You just get so tired that your eyes just close for a second. You're like, oh, it'll be fine, and then you just fall asleep. That's OBS. It is. You got it. Yep. It's OBS right here. We got ourselves some OBS. Open Broadcast Studio. I can't chat in Twitch 10 minutes. Oh, there's like a limit. So I'm not like a partner or anything on Twitch. I've only got YouTube partner. I don't have Twitch. So Twitch is new. Okay. Let's see where we're at here. So let's see. All right, tokens looks good. All right, let's try this again. All right. So we've got our first bug. Key.t. Do we need this? That's what I'm wondering right there. Do we need that? Okay. 1010, but got 1010, but got 1028. Let's see. Expected size for the first two dimensions of batch 2 tensor to be 128. Yeah, that sounds about right, but got 1010. You got 1010? Why'd you get 1010? Why'd you get 1010? Gotta go, Lutz. Okay. Good to have you here. You also watch anime? Me too. Yeah, there we go. 500 plus anime on Japanese language and 100 on your own normal language and didn't even understand properly, but still Japanese. Yeah, oh, it's good, isn't it? It's so good. Watch One Piece. It's the best and the longest anime. It's still going, right? It's like The Simpsons. It's still going. They don't need to be transposed. Okay. Yeah, I figured because the mat molt should automatically, and since they're also equivalent, they're both the same essentially. They should be good. They should be good. All right, so La 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 la. I want. So, but got 1010. So it's here where the problem is. So what I should do is I need to return mask. Here, let's just return query real quick. And then I think we're gonna start the debugging process. Okay. Oh, hey, there's the problem right there. All right, we figured out what the problem was. The attention, the query, it's not even a tensor. Naruto form, you completed Naruto, nice. So there's Naruto, there's Shippuden, and then there's Boruto, right? Next generation. And did you get all the way through? You got all the way through Naruto. Did you get through Shippuden as well? And probably not Boruto. Me again? Hey, but Vadinish, good to see you. Welcome on back. My brother is obsessed with One Piece. It's great. It's great. Hey, good to see you guys. Hey, Clinker Plays, good to see you. Debugging and debugging. A weak typed language is a nightmare. I know, but it's okay. I'm very used to it. I did JavaScript and which is an untyped language when I was children age. Quick fix, you don't like anime? Blasphemy. Blasphemy. Is there any math required in what you're building? A little bit, yeah, there's a smidgen. The good news is, the computer does the math for you. So you can do that. Yeah, the most heavy math that we're doing is right here in our attention mechanism. This is the heaviest math that we're currently doing. You like The Simpsons? Nice. Yeah, Simpsons did it first. And Boruto as well. Okay, so I'm still on Boruto. So I did Naruto, I did Shippuden, and I am partway through Boruto. I think I'm like halfway through Boruto right now. You liked it. Oh, previously you liked it. You used to like it. Okay. I gotta admit, Python's still easier to debug compared to Overlord JavaScript. Yeah. Python's a little bit easier. Yeah, JavaScript's got all these weird, strange oddities that you have to be aware of. Just messing. Oh wait. Hey, all good. All good. I didn't know. I mean, it's fair to say that I myself as well liked The Simpsons. I still like The Simpsons. I just haven't seen it recently. But don't even start One Piece. Oh yeah, it's long, right? There's hundreds of episodes. How many? Are there thousands of episodes now? Let's see here. How many episodes on One Piece? How many episodes One Piece? Yep, there's over 1,000 episodes now, you guys. One Punch Man. Oh, Clinker Place. That's on my list. I've seen some episodes. I really want to watch it. It's spawned a new generation of AI of anime, right? One with just One Punch Man, it's created like a whole other arc of types of animes, and I'm watching those, and I like them. Don't use JavaScript, instead use TypeScript. Hey, there you go, Malcolm. Use the modern approach, TypeScript, you guys. There we go. The modern approach. Okay, where are we at? All right, so I see the problem here. Our query just happens to be incorrect. The forward isn't correct here. It's wrong. It's broken. All right, so our forward on our model is a problem. So where are we at? So this is my transformer. The forward. See, right here. That should be perfectly fine. Right here. Look at that right there. What's the deal? We did it. Right there, forward, Steven Former, right there, and then we have it here. It's perfectly fine. You wonder why I haven't made hints in Python mandatory, kind of like TypeScript. Oh, I wonder why. Well, that's right. So you could do some typing, right? So you could say like torch.tensor or something like that, right? That's what that's got to be. You could do something like that, maybe. I don't know. I choose not to, just to keep the code a little bit more tidy. Nice. I completed Naruto only. Oh, not One Piece, not Dragon Ball Z, right? All right. Dragon Ball. Only completed one inside Big 3. Oh, I watched too much animes. It's really easy. There's so much anime to watch. Use Blazor from Microsoft. Blazor. Wait. What's Blazor? MS Blazor. I feel like I should know this. Hold on. Google Microsoft Blazor. How do you say that? Blazor. All right, what is that? Free open source web framework that allows developers to create interactive web UIs using C#. Oh, instead of JavaScript. C#'s a great programming language, right? I like that one. That's a really good one. .NET, you guys. Remember .NET? When it first came out, it felt really nice. It was like, what was it? It was Microsoft's answer to Java. This is what that was. Okay, so no, not that again. Hold on. I want the transformer. Here we go. So the output's incorrect. They don't look proper there. So what do we do here? Where were we at here? Return query, tensor. Here we go. All right. And then that's the old forward. You know what we really should do is I want to keep all this data, but I'm getting mixed up here. I'm getting mixed up. Build an AI agent that watches all of One Piece episodes and prepares for a full-on corporate report. Clinker. Wait. You're feeling the AI fever, aren't you? You're getting productive with the AI. You're getting so good that it's creeping into your fun time. It's creeping into your fun time. You can't do it, but vibe code it was a choice to protect code. Oh, the vibe coding, you guys. No. You didn't add AI on started. Wait. Completely. Well, wait, what do you mean? Clinker plays too much tokens unless it's local. So many tokens. It would be a lot of tokens to do that. One Piece, there's so much One Piece to have it watch all of One Piece. All right, you guys. Let's keep going here. I want to do something a little bit different here. So CP transformer to, I'm going to call it new transformer. Well, how about this? Custom transformer.py. We're going to close this now. Get status. Let's add everything. Get status. Get commit AM. Let's see. New transformer file. Transformer file for easy. Push the main. By custom. See, Python custom. There we go. Hey, y'all, video games, good to see you. Welcome on back. Good to have you here. Happy Wednesday. Hope you're doing good over there. Quite the opposite. It feels like a burden of something that is being imposed upon us. Oh, Clinker plays. Yeah, I know, right? You want some AI? A little bit of AI. Here you go. You're working on an antivirus now. Oh, quick fix. Very nice. Very nice. Once you master the Python language, I will work on a project where I will build. No, Malcolm, no! You deleted it before I could read it. Okay. All right, so let's go into here. I'm going to delete everything I don't need anymore. So where is the stuff that I wanted to do here? Where's the stuff I wanted to do? We got a lot of to-dos here. I'm going to delete things that we don't need. Okay, positional encoding. Looks good to me. We built it our own. We are not going to use swig glue here because it won't work for our current method. Rethink tokenizer, which we will do later. We've got our transformer here. I'm going to delete this for now. And then we've got our positional coding embedding. Looks good. We did that right there. That should perfectly work. Oh, positional encoding. Yeah, see, we did it. We did it. That should be everything we need right there. See? Whoops, control backspace. Hey, no worries. Rip Malcolm's message. I know. I was like kind of excited to see what it was. What if you can make an AI that can make stories and print it by itself? Yeah, video games. We could do that. We 100% can do that. We've got the capability. We're on our way right now. I'm almost complete. Hey, how's it going there, Kit 91? Good to see you. Hi. Oh, hey, you're over here. Okay, so you came in from YouTube. Oh, hey, very nice. You found me. Hey, all right. Good to see you. Hi, exclamation point. Good to have you here. All right. Build a desktop recording mouseless keyboard macro, but I don't know which GUI library. Should we use Qt or Tinker? I don't know. I've not personally. I don't know. I'm not sure. Right? It's more comfortable for me to use Twitch. Oh, nice. Yeah, I watch a lot. I watch a lot of YouTube. I watch a lot of Twitch, and I watch a lot of anime, and that's about it. Had to delete because I had to make changes. All right, sounds good. No worries. I was wondering. Sure, you meant to add positional encoding to the token embeddings. Yes, right here. We got our embeddings. We got our positions. Right. Positional encoding. Yeah, we got our embedding. Looks good. We got our transformer. And that should do it right there. So print positional encoding and return positional encoding. All right, let's see what we got here. CD, desktop, transformer, Python, custom. All right. I didn't like that. Why? What's going on here? Oh, wait. Actually, no, this is fine. Okay. Because we printed it out. That looks correct. This is correct. Okay. So we got our position. Looks good. All right. Old forward. Let's delete this. We don't need this anymore. Okay. Sometimes you run a whole anime in the background to binge watch it and work at the same time. Oh, that sounds like really cozy. I like that. See, I'm sure I'm using malware bazer. What is that? Quick fix? What is malware bazer? Or maybe an AI that can generate new memes. Yeah, video games, yeah. Oh, we could build so many fun things on here, can't we? We sure can. Programming memes, nothing else. Only programming memes. All right, that is such a good idea. A quick fix that's going on the idea list. Stream ideas. Here we go. Let's make a new one. All right, create a new post. Here we go, you guys. A generative AI model only creates programming memes. Only programming memes. So, there we go. Create the post. All right. Only for programming memes. Hey, there we go. Good idea. I like it. That's great. That'll be a lot of fun. We can do it. Once we get, and we're building our own transformer right here, right from scratch. So we should be able to do similar with our tokens. We can build any kind of token we want, and we can generate images. It could generate text. It could generate whatever we want, you guys. Why did the programmer not get married and stay in permanent relationship? He didn't commit his code. Torva, I see what you did there. I see it. I get it. Source code version. You got to get that source code versioning in there. Where will we find so many memes to learn it? Oh, yeah. We probably want to go to, what do you call it? Maybe some Reddit. A little bit of Reddit. Maybe we go to, let's see. Let's get our data source. All right, data source. We could go Reddit. We could go to Imgur, right? Imager. Okay. And I don't know. Where else would we go? I'm not sure. Will quantum computing have any effect on AI? Like, will it compute faster? Yes. Malcolm, I think that's when we're going to get AGI. It's when we create an AI algorithm that can run on a quantum processor. When we have enough quantum bits to be able to create lattices that can overlap at the same scale as today's modern lattices. It'll basically become an AGI at at that point. And it will get exciting. It's gonna get exciting then. We need it. We need it. I built one. I built it, but it's only big enough. The CPU was only big enough for one layer, and it was very small. It was low rank is what they call it, low rank. You got a lot of ideas, but you should write them down first. Hey, definitely share them in here. Share them in here. Why do programmers prefer dark mode? Ooh. What? Why do they prefer? Andre Karpathy video. Hey, yeah, Andre Karpathy. Great AI scientist of our era. Cloudhead, what do you got there? And right in embeddings is what I do. Oh, wait. I'm going to copy and paste this into my code editor. Light subtracts bugs. Quick fix. I should have known it. That's why dark mode, you guys. Because light get rid of the bugs that we have in our code. Like right now, I have got bugs in my code. I need to debug them. So dark mode, it prevents the attraction of bugs. Although not completely. Partially. All right. What did you type here? So you said this. What is this? You said position torch. Okay. I like how you put semicolons in here. I really like how you put the semicolons. That makes it a lot easier. Ooh. Let's see. What is this? Okay. So arrange 0 to T long tokenizer. This is the tokenizer. I don't know what these are. What are byte pair encoding, position, positional. All right, so you've got your positional encoding, and then you've got a dropout layer, and you add these together. Is what I do. Okay. Hey, Cloudhead. T is sequence length. Oh, got it. Okay. Got it. Okay, yeah. So this is your positions, your tokens, positional embeddings, and then you add them together, right? To apply embedding plus positions, which is what you do. You add them. You do a dropout, and that's what you got. You did it. WTE is token embeddings. Oh, token embeddings. Okay, token embedding. Got it. Positional encoding. Weights, positional encoding, token embedding. I see there. I like it. I like it. Idea number 3, an AI that can make ARGs scripts. What's an ARG script? ARGs means a type of story that's fake. Oh, it looks like it's real, but it's all scripted. Like Pet Scoop and Catastrophe Crow. Ooh, yeah. Okay, a story writer that builds, it makes it real. It makes it real. I like that. Yeah, video games, nice. SQL query walks into a bar. I know, we got another programming joke. Walks up to 2 tables, asks, can I join you? Hey, SQL, I get it. You want to join the tables, right? You left join, outer join. What kind of join are you doing over there? I see what you did. SQL jokes. Wait, what's with the TUI you wrote before? Oh, wait, a TUI? Did we write a TUI? What's with the TUI you wrote before? So did I write a TUI? Terminal user interface. I don't think I've ever written one. I don't know if I did. I don't think, we could write one. I know how to write one. They're actually pretty straightforward. I just don't think I wrote one. Gotta go. All right, yeah, video games. Thank you for joining in. Good to have you here. All right, let's keep going on our code, you guys. We got about 15 minutes, which is enough time to maybe debug some of what we were currently working on. So let's see here where we are. I'm going to get rid of this old code. Get rid of that. Okay, looks good. Okay. So we got our batches. We got our outputs here. And then you played with the colors of the progress bar. Oh, yeah, that's here. That's supposed to still have that. This is called a heater. So you see here on screen, it helps me visualize. So you can imagine this as what it would look like for each token. Each token, each word would look like this, right? This could be what the embedding looks like for each word. So I do word level tokenizer. The industry has kind of standardized on byte pair encoding, which helps reduce the dimensionality of the total vocabulary because you get compression. Now, I think you lose some things if you do that. So I'm using full word token dictionary creation. That's what I'm doing. Yeah. So we could use this. It's a visualizer. It looks really nice, right? I needed it because it just helps me see better. It helps me think more, right? Different ways to visualize your data. Very important. Very important, you guys. Here we go. All right. Would the bigger square be next to the key or the word? The bigger square? Would the bigger squares be next to the word or keyword? So, yes. So each of these, so let's say each of these numbers that you see here on the screen is a single word. So you kind of think of it as a line, right? So this would be like the word cat, right? All those numbers right there, they mean one word, cat. And if you were to visualize it, it looks like this from a color perspective. So that's kind of how that works, right? That's kind of how it works. Just a smidgen of working right there. Okay, so output, print. Let's do the print output here. Output. All right, models, features, our input, target. So we're going to do targets later. All right, we don't need to worry about that right now. All right. I shouldn't see. Here we go. Okay. No errors. Okay. So we got an error right there on 140. 140. Right here is a problem. Okay. On our we're not decoding anything. Oh, when we're building the decoder. Oh. Why? Why though? This is weird. This shouldn't be a bug. We used to make the graph features like where you did. Oh, really? A 10 by 10 matrix and learned our model instead of the matrices. Oh, yeah. 10 by 10 matrix of the features and learned our model with it instead of matrices. Are you optimizing? Are you making it like what approach? Like what was your outcome? What was your goal? I'm actually kind of curious about that. Kit 91K. I'm kind of curious. Okay. So it has a problem here. Decode. I'm not decoding anything though. Oh, yeah, I am. It's like, I'm not even doing it. There. Okay. So far, so good. Okay. So let's get back up to our transformer here. All right. So we got the positional encodings. We're returning them. So instead, let's go to our outputs before. So the Steve informer, right? We need to get our forward pass here. All right, so in our forward, where are we here? So we have to be, let's do return out here. All right. You look like my grandpa. Hey, how's it going there, Adrian? Welcome on in. Yeah, I'm old. That's what you look like when you're old. You look old. I'm in my 40s, you guys. Why did the Python programmer break up with Java? Why did it happen? Why did the Python programmer... two competing programming languages. Just Kit. All right, sounds good, Kit. Sounds good. Because too many classes and no self. Oh, yeah! Python with the self. And Java, everything's a class, right? So everything's an object in Java. Everything's an object. Okay. So let me see. Aha. All right. So, we're making progress. Oh, that makes it good. Okay. Okay. So that's only on the attention query. Okay. So we only are returning the query itself. So that part's fine. We should return at least an output here. Return out. All right. Let's try that. So that fails. So we're back to where we were. So Y is my answer. So let's see. Let's do the query again. So we're going to return the query, and then when we do attention on our feed forward, we're going to return that as well here. So that will be the query. Okay. So no errors, no bugs. Looks good. Okay. So that's our full embedding, positional encoding, and batch. Yes. Yes. All right. So far, so good. So far, so good. You look young, Steven. Sergio, thank you. Appreciate it. That's very nice for you to say. Very nice for you to say. What are you building? Just joined. Hey, Vickman. Good to see ya. We are building our own custom transformer. We are. We did. We got started on Monday. We wrote out our entire plan. We succeeded at getting the end-to-end for a full transformer, the entire algorithm, and including multi-headed attention, which is what this is right here. This is multi-head. This is multi-head attention right there. And then you can cat the heads, you run it through feed forward, which is just some linear layers with an activation. And then you have a linear output that repositions all of your parameters to target vocabulary size so you can pick the biggest number. What's going to be the next word, right? The next word. What would be the next word here? The chat was happy today. Let's say maybe the word is today, right? So our final output would be the word today. Today. There we go. Perfect. Unfortunately, it's almost only thing we do. It was a final project to predict the stocks. Oh, there you go. Financial AI. Ooh, quant. Yep, you're doing some quant there. Small language model. You got it. SLM. Thank you, quick fix. Okay. So my intention should return output on my forward. Am I printing anywhere else? I'm only printing in one spot, right? So print, where are we here? Print, there we go. Okay, those are fine, those are fine. I do want this, okay. That's it, right? Those are the only prints I got? Perfect, perfect, okay. So yeah, I've got the embedding, that works perfectly. We're good there, we're good there. Only thing to remember from this project, it's the only thing you remember from this project. Ah, got it. The features of the 10x10 matrix. The features, you guys. All right, so is this batch? I think it is, yes, because you've got your words, your inputs, and batch. Okay, sounds good to me. LLM from scratch victim, exactly. That's exactly what we're doing. You got it, you know it. That's what we're building right now. All right, so that part works. I do feed forward on my model. I print the output. I break. And then I'm going to set my epochs to 1. I'm going to get rid of the old batch here because we don't need that anymore. We're just going to say get batch as a regular batch. /new. Get rid of this. Hey, is it possible to make stock predictor? Yes, 100% accurate. The good news is you don't need 100% accurate to get profit. You basically need better than a random number generator, right? So if you get it right 50% of the time and you make you place your bids and they're uniform size, and you're right 50% of the time, you basically break even. So the problem is, if you get less than 50% of the time accurate, you lose money. But if you get more than 50%, like you get 51, then you can make profit. And if you get 84%, then you can make even more profit. So it doesn't have to be 100%. 60 is good, exactly, quick fix. 60 would be really good. That's really good. And did we do that on stream? Yeah, we did. Yeah, we did. We did the pattern that a lot of the world uses by checking the news sentiment associated with each stock ticker. We did this using a modern embedding, and we succeeded. We did. We took news headlines, got them at the moment that they released. And we didn't place real bids though. We simulated it, and we got to 84%. We got to 84%. Pretty good, right? Pretty good. We open sourced it. It's in our Discord. If you can find it, it's around there somewhere. It's in there. Yours for free. A very own quant algorithm. All right, where are we at here? I want to go a step further. So let's go back up to where we had a problem. So let's see, query key projection. Here we go. So let's return the key. It should be identical-ish. We should not be able to tell the difference between the key. It could, yes. How does it get rid of noise? So you get rid of the noise by focusing only on the specific features, right? The inputs. They're going to be useful. And it's very important. I found that it failed if you gave it too much history. You need to give it modern history, like 6 months of data, not 20 years, because all that 20-year data causes noise. So I saw 6 months performs better than giving it too much data. So there's a tip for you guys. There's a tip. Perfect. I'll put your whole life savings in. Thanks. Financial advice, Steven. Yeah, bro, fuck. Yeah, there you go. I should start with like €5 IRL. Yeah, that was a good start. Start with, yeah, exactly. Test money. Test money. Thank you, Sergio. Absolutely. Absolutely. Okay. But what if we want historical data? Well, you can, if you want it, you can have it. It's there, it's free, it's available. If you want historical data, it's available. You can do it. The problem is though, the models that I created, when I added too much historical data, it didn't match the investment patterns that exist today. A lot of investment in trades, they occur with a machine. They are through some sort of robot, right? An agent or someone's code, their algorithm is doing the trades for them. So these types of patterns change over time. And it's every 6 months, I think it's just a little bit different. So it's important that you're up to speed. You train your model on the market data for the recent trade patterns, right? I regret that I started this theme. The features were like technical indicators. That's what it is. That's what they are. You got it. Hey bro, how to keep doing stuff that matter when things get hard. Mohammed, how to keep doing when it gets hard. Well, here's the deal. Here's the deal. Most people give up, and the value that you can get out of the things that are hard is even more because of it. So is it worth it? Yes. The motivation to succeed, it's tough sometimes, right? It's tough to get there. If there's a constant failure or a constant roadblock or something's broken. The good news is, if you keep pushing forward, you will be able to achieve. And it just takes a while. It's okay. I think it's one of the greatest technologies of humanity is our ability to recognize failure and what doesn't work. It shows you that you know that you can make an improvement. If we didn't know what failure was, we would be stuck. We would not have moved forward. While they're waiting for problems to pass, life passed. Yeah, it'll pass you by. Thanks for the information, Steven. Hey, you're welcome, Malcolm. Absolutely. What do you think of AI agents or N8N or CodeTool? Vicman. I use AI agents all the time. So I've got anti-gravity here. We've got anti-gravity. We've also got Codex, right? We've got Codex right here. And we've got Claude. I use them all. They're all really good. You just let a dry run test. Hey, Torva. That's exactly. Yes. Torva, you're smart. You're smart. Keep doing the things that matter. Yes, exactly. That's the way to do it. Important the folks. The current quant bot Steven uses Silicon, so he need a Mac. That's a good point. I am using a Mac. All right. Don't give up. It's the life lesson. Quick fix. Exactly. Yeah, you need to keep it up to data since trend trading and the fact that large quant firms are trading to influencers, the market, to influence the market. Yes, exactly. The big players. I got your daily dose of Steven motivation. Hey, there you go. All right. For trading, use a retrieval augmented generation and delete 10 months of data and always update live. Yes, always keep up to date. Always keep up to date. Starting is what everyone can do. Persisting is what we need to do to succeed. Yeah, persisting. It apparently is the key. It is the key, you guys. All right. Let me see if I can at least solve this next bug here. So let's get rid of these windows. There we go. Okay. So let me print the key. Desktop, transformer, Python, custom. Let's see. All right, got the key. Good. We got the key. Looking good. So now let's do query key. Let's just do query at key. Let's try this. Let's try that. See if we can do a matmul. And maybe we need to do a transpose. Let's try that. Okay. Still a problem. Okay, Y. The size tensor of 10 must match the size tensor of B at 128. Non-singleton dimension 0. This should be working. Why it not work? Why it not work? They're like the same dimension. Here. Let's try this. Print query.shape and key.shape. Now what is a retrieval augmented generation? OMG, I'm still learning new terms. Hey, RAG, what is RAG? RAG is just a search engine that you use to find context. And that context is just text. And then you use that in your search. So say you've got a user, they submit a prompt. They say, here's the prompt. So they say like, Google, what is RAG? Here's your prompt. So it's gonna take your keywords, the word what, right? The word what right here, the word is gonna get dropped because there's not much there. It's a nonsense word, although it could still have meaning. And then you've got RAG, which is a keyword. So you've got the keyword there, right? Then you're going to take that data, throw it into a database to search. There's several types of search. There's keyword search, reverse index lookup search, and you've got full text search, and you've got vector search, which is similarity. The idea with RAG is it also adds in vector. You combine all the results between each of those searches, only capture the top searches that fit the most likely probability of related information. You append that information into a LLM prompt, and then the LLM will answer based on the context. That's it. That's all it is. It's really easy. RAG is like fine-tuning without retraining. Yeah, that's a good way to say it too. Exactly. You don't need to fine-tune. For large files too. Yeah, exactly. Yep. So it just takes your prompt, extracts the words, looks up related text in a search engine or a database of some sort, grabs that data, and it appends it to your prompt. And then it has the LLM answer in natural language. All right, you guys. Let's see if I can figure out what's going on here. What is the... Why it not work? Print. Okay, query shape. Then we do key shape here. And then we print it out and we should be good to go. All right. So why is that a problem? Like it should be working perfectly fine. All right, Python custom. Here we go. Where's my shapes at? Here we go. See, they are the same shape. They're the same shape. That should be perfectly fine. Right there, look. It's a batch of 10. So how do I deal with that? It's 10 words. Each word is 128 tokens or 128 features in your embedding with a batch of 10. Bruh. Oh, wait. Oh, does it work? It almost works. It almost works. I just don't know why. It's not. The shapes are identical. So why is it not working? I guess if you... What if we transpose... Let's see. .t. What does it look like when you do .t? That looks like this. Oh, wow. Okay. So that's... Can you transpose at a different dimension? Turn down the music. Oh, yeah, sure. There you go. How about that? Is that a little bit better? Okay. So the problem is I'm seeing here really quick that we need to solve for this. Can we set, when we transpose, can we change dimensions? Google, PyTorch, transpose. Maybe we need a different view. Good. Nice. Nice. Let me see here. What song was that here? All right. So I need to consider removing that one. Okay. All right. We're almost here. I think the plan is I really want to make sure that I get this one thing good. PyTorch transpose 3 on different dimension. How do we do that? Let's do a quick little look up here. All right, transpose. Oh, we can just say x.transpose. Okay. Swap. Right, that's a regular transpose. Swap dim 0 and 2. Do we want on... Can we transpose on different? So I think... Let's just try transpose. Okay. Transpose on... We'll do 1, 2. Can we try that? What's that going to look like? Hey, Trevor! Good to see you! Welcome on in. Happy Wednesday. We're just building ourselves our own custom... Hey, right there. All right, so maybe that'll work. Maybe that'll work now. I don't know. We're going to find out. All right, let's try this. There we go. See if that's better. Is that a little bit better? So we got batch. We've got our dimensions, and then we got our words. Why do we need to transpose? We got to get the mat mult to work. We got to get the mat mult to work. That worked. Oh, it worked. Hold on. Out equals return out. Oh, here we go. There we go. Okay. All right. Now we're doing it right. Okay. So now that we got the right shape, that's the one thing I wanted to fix. That's the one thing. We need to transpose because we're doing a matrix multiplication. When you do that, you need to make sure that your inputs have a shared dimension. It's got to be a shared dimension on one of the sides. Either the width or the height has to be a shared dimension. If it's not, then it won't be able to transmute. It basically there's not enough iterations. It'll overlap and it will fail. So a square works really good. A rectangle works fine. You can have dissimilar rectangles. However, the width dimension needs to match the height of the second rectangle, right? So your height and width need to match in between in order to do a proper mat mult. It's all about matrix multiplication. That's it. Good morning, Creeper. Hey, UPPCO. Good to see you. Welcome on in. Happy Wednesday. Okay. So since we did that, do you think we can do this next right here? Can we do that part right there? Oh, that's cool. Yeah, it's pretty good. It's pretty neat. Yeah. I think it's pretty smart. Okay, so I think we did this correctly now. I think we're good to go. Yay, I know, we did it. This part right here was a problem that we were stuck on for like 30 minutes. The good news is we simplified all of our code base while we're doing it. Yay, we did it. Okay, let me see if I can get this part right here working. I think we could because this is a scalar and that should work perfectly fine. That should work absolutely perfectly fine. So let me run this again just to double check. All right, looking good. We got our transposition, our output here. Yep, okay. Yep, looking good. All right, so now I can hide these guys. And then I want to try adding in this right here. So let's add the scale. So we scale. This is the query key, and then we're gonna add the scale next. Out equals out divided by the scale. There we go. It's got to be a float division, not an integer division. Let's try that. Let's try it. Yeah, there we go. Hey, we're making it happen. Some math blah, blah, blah. It is exactly math blah, blah, blah. You got it. Blah, blah, blah. All right. So, all right, that part's good. That part's good. Can we get the mask as well? I think we might be able to. Maybe. We might be able to. So size 1, yes. Okay, so we did that. So that does the scale. Now we need to do, so we can hide this. We don't need that anymore. Now we can do the mask. See if we can get the mask going. Are we gonna get our full self attention? Oh no, the mask failed. Tensor object is not callable. Wait, really? Wait. It's, how do we, oh, we need to do, okay, so do we do this? How do we do this? Like that? Is that gonna work? How about that? Okay. Well, that's a problem. Mask. Let's try that. Okay. All right. Well, it's giving us some numbers, and the mask is masking everything. It's 100% masked. It works too well. It worked too well. Anon AGG, good to see ya. Welcome on in. Happy Wednesday. Random one, what's the Neo Vim plugin you can't live without? Oh, Anon. So that, for me, I use regular Vim. So I can't say I've got a favorite. Glad for your nans. I know, look at all those not of numbers. The mask, it worked too well, you guys. It worked way too well. That is a full-on, overly generous mask. Let's see. See, this is the actual mask right here. So it does multiply. The problem is, it destroys everything. It destroys it all. Like, look at that. It's gone. It's just absolutely gone. It's completely gone. I need to see how to apply the mask. There we go. Yeah. All right. So this is broken. Fair enough. Yeah. What about you? What's your favorite plugin? For me, I just use regular Vim. I like having a syntax highlighter. In JavaScript, there's a joke about banana. Wait, there is? Like the prototype, maybe? Wait. Oh, about the nans. Oh, right. The not of numbers. Banana. Banana on the JavaScript. What does a spider do in a browser? It browses the web. It could. It could. The spider browses. It crawls the web, right? It crawls. Right? Crawl the web. Crawl the web. All right. Is that the answer? It is. Hey, we got the answer. All right. See, we know technology, except for we can't apply a mask. How do we apply a mask? All right, let's get some help. Let's get some help from the Giminis. All right, Jiminy. Here we go. All right. Ba plus a. Oh, is that going to be a banana? Is that going to be a banana? All right, we're going to try it. We're going to try it. All right. Let's see here. How to apply mask torch. Okay, let's try it. Node. All right, let's do it. Ba plus. And we do plus a, which is going to be a banana plus a. Banana. Hey, we did it. Banana right there. Boom, right here at the bottom. At the bottom, banana. That's a banana right there. We got it. Can we do an actual banana? There we go. Actual banana. There you go. That's JavaScript. It counts. Banana. Plus a. Let's do another one. Plus a. There we go. We got to do, and then a plus here. Banana. Banana. Thank you for bringing that up, Kit. Okay. So, let's see if we got an answer. All right. Mask filled. Oh. So we have to do something extra with our mask. Apply the mask. Okay, so I'm not familiar with this. I've never done this before. I've never applied it obviously using Torch. We could create a mask. I feel like we shouldn't have to do this. Oh. So wait, X mask. Okay, let's do that. Let's try that. So it's out mask, like this. Out mask. Like that. Can we do that? Custom. No, it doesn't like that. Okay. Torch tensor mask equals greater than 0. Greater than. Okay. We have a very specific mask. Filling mask spots with a constant. Out of place. Okay. All right, you guys, this is what we have to continue on tomorrow. All right, so this will be the plan for tomorrow. We will figure out what the mask is. We'll figure out how to apply the mask. That'll be tomorrow's goal. Can torch where condition? X torch tensor. What is X? Where? Torch where? Oh. Oh, no, yeah. That's a condition. Okay. Condition X. Then you got your X. Okay. This is what I want to figure out. So we've got it. Torch tensor. We've got our inputs, right? You get our mask, and we got our mask. So out.mask filled. Let's try this. Let's try this real quick. If this doesn't work, we'll figure it out tomorrow. UPPCO is a small man, is what you said it, not me. You said it. Okay, let's try this. Out equals. We're gonna say out dot mask filled. We've got our mask float infinity. All right, let's try that. Nope, still not work. Okay, mask fill only supports Boolean masks, but got a D-type float. Okay, so we need to figure out how to do this. All right, that'll be planned for tomorrow. You guys, thank you so much for joining today. We'll be back tomorrow. We will continue with building our own custom GPT. We are very close. We are very close. We've finished. We're code complete for the most part. We've got a dictionary to get our vocabulary proper because we have to tokenize our actual Python code file itself so it can replicate, right? We want it to be able to generate itself, train on itself, and then regenerate itself in an infinite loop. See ya. Have a nice evening. You too, Kit. Thank you for joining, everybody. Sergio, good to see ya. UPPCO, good to see you. Anon, also as well. Quick Fix, thank you for joining in. JBL, Trevor, Malcolm as well. Torva as well. Torva, of course. Vicman, and everyone else. Thank you for Brofolk, you as well. You as well. All right, you guys. You're a genius. Whoa, Seventh Son, thank you for saying. Appreciate it. It's really nice for you to say. We're going to continue with our GPT tomorrow. We're going to build it. It's going to work. It's going to be so good. Hey, Crantony, thank you for saying hi. We're going to head out now, you guys. Quick Fix, good to see you. Okay, have a great rest of your day, everybody. Bye. See you tomorrow. Leaving already. Yep, you got to go. Catch you in the next one. See you guys. Bye, everybody. See you next time. See you tomorrow. Same time tomorrow. Bye.